Okay. So six participants. एक मिनट और वेट कर लेते हैं. ठीक है. Okay. So let us start. You can see here that velocity is directly proportional to angle theta, means there is linear relationship. Okay. So by knowing this relation with velocity and angle, and also the position of maximum velocity, we can draw the velocity diagram for uniform acceleration and retardation. So this you can see. This is the curve we have drawn for angle of rise. For angle of return also you can draw the curve. If it is given that even during return the motion of the follower is of uniform acceleration and deceleration type, then you can extend that curve. You can see that here. Now numbering you have to do start from top 7 dash. It should be like यहाँ पे कितना हुआ था. I will say how to number it. Okay, instead of ABCD, we will take a continuous numbering. So displacement, velocity and acceleration diagram. We know that velocity is directly proportional to angle theta. This is the theta angle. So it is linearly increasing, as you can see in the formula here. Okay. So it is linearly increasing and it is going up to maximum value when theta is equal to theta 0 by 2. This angle is theta 0 by 2. And after that there is retardation, that is deceleration of the follower. Its velocity is continuously decreasing and reaching the zero value at the end of the rise period here. Then for return you can draw the velocity in this direction like this, because the follower motion is in opposite direction, so its velocity has an opposite direction. Then you know acceleration is constant. We have seen acceleration value is constant, so you can draw a constant line, a horizontal line at this height, and this height is nothing but your whatever is the value of your acceleration, this value 4h omega square upon theta 0 square. You can take it by judgment, no need to measure this. I mean, you don't need to take any scale to draw it. This is maximum acceleration. Then on the later half, the second half of the follower, speed is reducing, means there is negative acceleration. So that's why this block is shown in the below the x line, below the x-axis. Then during return stroke, again the acceleration is in negative direction first, and its value will be different for return stroke. For return stroke, here in place of theta 0, this formula, in place of theta 0 you have to use theta r, that is angle of return, in order to calculate the acceleration. So you might get these blocks of different sizes during the return stroke depending on theta r, like this. Okay, in this way you will draw the velocity and acceleration diagram for the uniform acceleration and retardation type of motion. So you draw it like in 2 minutes, these triangles, and then we will proceed for the last type of motion, that is cycloidal motion. Drawn, draw again. This is line smash curve. इसको हाफ से डिवाइड करो, और ये हाइट आप कोई भी ले सकते हो, एनी हाइट. Just join it like this. Okay. So next is the cycloidal motion. What is this motion? You know, a cycloid is the locus of a point. This point is on a circle which is rolling on a straight line. So you can see that this circle is like this, and this circle is rolling on a straight line. So what will happen? After some time, this circle will have this position. Then after further, it will have this position. So you have to trace the position of any one point. For example, it is the circle ka position 1, 2, 3. So you take any one point on circle. For example, I am taking this point on the circle. When the circle will roll, this point will rise up. This point will rise up here. So somewhere here it will come. Then when circle will roll further, this point will again rise up. So it might come somewhere here. And when you join these points with the smooth curve, then this particular curve which you have generated is known as cycloid. Okay, so we are giving such cycloidal motion to the follower, means its displacement, the follower displacement from the straight line will be proportional to this motion. It will be governed by this motion. So at particular angle theta, what will be the height of the follower? That will be governed using this kind of construction. So how to draw the displacement diagram for a cycloidal motion? Okay. So what we do here, again we draw a rectangle. It is almost a common practice now. Then its height should be equal to h. H, you know what is this? H is the lift of the follower, the distance between its lowest and highest position is lift of the follower. Then this length you can select anyone, okay, which you can divide into 6 number of equal parts. We are keeping it 6 only. You can take 8 also, but 6 is advisable. That will reduce your time, construction time. If you take 4, just 4 division, then further time will reduce, but accuracy will again compromise. You may not get a smooth curve. To get a smooth curve, you know you need number of points. More the points, more smoothly you can draw the curve. So this way you have divided it into 6 parts. Let us say 0.1, just for convenience I am giving this numbering up upside. Vertical line 1, 2, 3, 4, 5, 6. This is 0.0. Now you have to draw a circle whose center will be this corner, lower left corner of the rectangle, and the radius of this circle will be such that it is equal to h, this lift of the follower, upon 2 pi. So if you see h will become equal to 2 pi r, that is circumference of the circle. When it will roll like this, its complete its complete periphery will be laid out along the line. This height will be covered, okay, like this. So radius of this circle should be h upon 2 pi. H upon 2 pi. Remember this. Okay, this circle you don't have to draw arbitrarily. Arbitrarily, what you can take? Only this length. Only this length you can take arbitrarily. Okay. Next, what you have to do? After drawing this circle, you divide this circle into same number of equal parts as you have divided this rectangle. So where to start from? So you have to start from this point. This point is 0. It is your vertical diameter. Okay. Now from here you have to divide whole circle into 6 parts. So a circle is your 360-degree angle. Okay. You have to divide into 6 equal parts. Means each part will be your 60-degree sector. So take 60 degrees. So it will be 90 degrees somewhere. You have to take with compass when you will be solving the numerical. When you will be noting down, no need to use the compass. Then this is the 60 degree. 1, 2, 1, 2, 3. Okay. 1, 2. This point is point 3. Next, same way, this half of the circle should be divided into 3 parts. So ये हो गया 60 degree. Okay. So this one is your 4. This point is 5. And it is your 6. Okay. Now these points 0, 1, 2, 3, 4, 5, 6. You have to project on the vertical diameter. So if you will project point 2 and point 4, so at vertical diameter you will get a point here. Similarly, when you project point 5 here and point 1, they will be coinciding. So here you will get 1 point. So how many points you have? 0 is already here. See, here 3 point. Here 2 and 4. यहाँ पे कौन सा point है? 2 and 4. यहाँ पे point कौन सा है? 1 and 5. सेंटर में कोई point नहीं है. ठीक है. After that, you join the diagonal of the rectangle first. So इसको center point से join करेंगे. Like this. So you complete up to this, then I will show you the further process. Say in 2 minutes you draw, then I will tell further. A rectangle draw किया, फिर उसके पॉइंट ये कॉर्नर लेकर r इक्वल टू h अपन 2 पाई लेकर आपने ये ड्रॉ किया सर्कल और उसको 6 पार्ट्स में डिवाइड किया, रेक्टेंगल को भी 6 पार्ट्स में डिवाइड किया. डू दिस इन 2 minutes. रफली ड्रॉ करो, अभी अभी स्केल से ड्रॉ मत करो, जब प्रॉब्लम सॉल्व करेंगे उस वक्त स्केल से ड्रॉ करना है। डन।
Yes, sir.
अभी सिर्फ रफली ड्रॉ करो, रेक्टेंगल ड्रॉ कर लो।
Done, sir.
ओके, सो राइट, नाउ व्हाट यू हैव टू डू, सी पॉइंट 3 यहाँ पे ऑलरेडी ये वर्टिकल डायमीटर पे है, तो इसको प्रोजेक्ट करने की जरूरत नहीं। 2.2 और 0.4 को वर्टिकल डायमीटर पे प्रोजेक्ट किया है यहाँ पे, ये पॉइंट सेंटर में कोई पॉइंट नहीं है। देन 1 और 5 ये पॉइंट पर है, और 6 और 0 ये पॉइंट पे। तो आपको व्हाट यू हैव टू डू, you have already drawn the diagonal of rectangle. Now you have to draw through these points on vertical diameter a line which is parallel to this diagonal. ये diagonal को parallel line from say from point 3. So I will draw a line parallel to diagonal from point 3 till I reach the vertical line 3. So here I will get a point that say I will say it is 3 dash. Then at this point, at this particular point, which points are there? 2 and 4. So from this point you draw a line parallel to the diagonal line. Okay, so that it will cut at vertical line 2 and vertical line 4. So I have to extend it so that it cuts the vertical line 4 here. So here you will get the point 4 dash, और यहाँ पे जहाँ पे वर्टिकल लाइन 2 कट हो रही है, you get the point 2 dash. Then which points are remaining? Point 1 and 5 are on this vertical diameter. So from here you start drawing a line which is parallel to the diagonal. Which line should cut 1 and 5? So 1 यहाँ पे कट हो गया, तो ये पॉइंट मिल गया 1 डैश, और यहाँ से ये पॉइंट अभी 5 तक लेके जाना है लाइन को। 5. Okay, so you will get somewhere here, and no doubt this point if you will draw with scale, okay, it will appear higher than 4. Then point 6, I think we have numbered it wrongly. Point 6 will not come here, point 6 should come here, so we have to renumber it. I think some mistake has been done, I will correct it. Okay, so point is that point 0 should come here and point 6 should come here. Okay, so you should start from this point. Okay, 0, then 1, 2, 3, 6. Let me check once. It is starting from here, this point. Okay. So see, this numbering is to be done from here. That is the, you can say that positive x-axis, positive x-axis. Okay. Now from here I will divide it into 6 parts. This first part, then second, यहाँ पे आपको थर्ड भी मिल जाएगा, फोर्थ, here it will be fifth, and here it will be sixth. Okay, now it will give us the results. Now what you have to do, you first you draw so here is your line 1. It is vertical diameter, right? So this 0, which points are here at this point? At this point, point 3, point 0 and point 6 are there, and point 1 and 2, point 1 and 2 is at this point. On vertical diameter you have to project. Then if you project 4 and 5, they will be here. Okay, now what you have to do, first you join the diagonal of the rectangle. Now from this point, at this point, which points are there? 0, 3 and 6. So at 0 line it is cutting here only. At 3 point where this vertical line is cut, that is 3 dash, and point 6 is also there, so here you will get the point 6 dash. Now at this point, point 4 and 5 is there, so from this point you draw a line which is parallel to the diagonal. It will cut at point 4, at line 4 and line 5. So where vertical line 4 is cut, that point you label as 4 dash, and here you label it 5 dash. Similarly, repeat the procedure for point 1 and 2. So if you will draw a line which is parallel to the diagonal, so here 1 will be cutting and here line 2 will be cut. So that is 2 dash, and here it will be 1 dash here. So say it is 1 dash. After getting 1 dash, 2 dash, 3 dash, 4 dash and 5 dash, you have to draw a line connecting these dash points. From this is the 0 point. So 0 to 1, your curve will go like this: 2, 2 dash, 3 dash, connecting 4 dash, 5 dash and 6 dash. So this will be your displacement diagram, like this. Are you getting the procedure how to construct the displacement diagram for cycloidal motion?
Yes, sir.
You have to keep in mind the procedure. Procedure is so developed that resulting curve which you draw, will be presenting the cycloidal motion. The distances will be proportional to a cycloidal motion distances between 2 points. So initially you can take, though cam angle has rotated through theta by 6, but the displacement of follower is small, and as it rotates further by an angle equal to theta upon 6, then uh, the distance traveled by the follower is greater. You can see it is increasing, then it will decrease in cycloidal way. Okay, so you note it down, then we will discuss the formally. In 2 minutes you note it down.
Done, sir.
Okay, now let us go to important formulae. So this is the formula of velocity. If you want to calculate velocity of the follower at any cam angle theta, okay, you can do so using this formula. Okay, velocity will be maximum at what position? So when this bracket factor will be maximum, then it will be velocity will be maximum. So what could be the maximum value of this bracket? It is 1 minus this cos factor. So what is the maximum value of cos? Cos का maximum value होता है, एक तो होता है +1, ठीक है, और एक होता है -1. तो अगर +1 यहाँ पे रखते हैं हम, तो 1 - 1 मीन्स 0 हो जाएगा, वेलोसिटी विल बी 0. बट इफ वी पुट value -1, then 1 minus -1 will become 2. So it will be 2h omega theta 0. And you know, when the cos value is negative -1, cos 0 is 1, cos 0 is 1, and cos 180 is -1, correct? Cos 180 कितना होता है? -1. So 2 pi theta upon theta 0, ये जो वैल्यू है, if it is equal to 180 degree, that is 180 degree means pi radian, then your velocity will be maximum. When it will be maximum, this pi will get cancelled. It will be maximum at theta 0 by 2. When theta 0 by 2 means when follower is at mid position, then velocity will be maximum and its value will be this. It is about the formula of acceleration, which is obtained by differentiating velocity with respect to time. So when acceleration will be maximum, when this sine component will be maximum. What is the maximum value of sine 1? So it is the value of maximum acceleration, and it occurs when theta 2 pi theta upon theta 0 is 90 degree, because sine of 90 is 1. So when 2 pi theta upon theta 0 is equal to 90 degree means pi by 2, then this value will be 1. So this pi will get cancelled and you will get here theta as theta equal to theta 0 by 4. Means at theta 0 by 4 the acceleration will be maximum, and at theta 0 by 2 velocity will be maximum. And what about this? It is also a cosine function, it is a sine function, so that curve you can draw. Let us see in displacement diagram. See, at theta 0 by 2 velocity is maximum, and it is drawn like a cosine curve, 1 minus cosine curve. So that's why it is not like this, it is like this. It is not like this, it is like this. It is 1 minus this. Okay. So maximum velocity occurs at theta 0 by 2, and maximum acceleration occurs at theta 0 by 4. After that it will reduce here to 0 and then go to in negative direction because velocity is reducing. Velocity is reducing, you can see. That's why it is in below the x-axis. Acceleration is below the x-axis. Uh, Getting this diagram, I will give you time to note down this formulae in 2 minutes. Then 2 minutes I will give to note down the diagram. Okay. And diagram, you can copy this. Immediately join back in